Welcome to the second video in Section 8, Working with Client-Side API. In the previous video, we were introduced to Akka HTTP module, and we discussed its structure. In this video, we will take a look at different levels on the client-side API: connection level, host level, request level. All functionality of client-side is implemented in the Akka HTTP core module. Akka HTTP client-side API provides 3 different API levels. Depending on your application's needs, you can choose from these levels. Very simple apps may stay on the request level API, and more advanced and performant ones may want to choose the other APIs. The connection level API is the lowest level client-side API. It gives you full control over when HTTP connections should be opened and closed, and how requests are to be sent across which connection. The host level API is built on the top of the connection level API, but it autonomously manages a configurable pool of connections to one particular target endpoint. This means Akka HTTP will manage a connection pool for you. The request level API is built on the top of the host level API to provide you a simple and easy-to-use way of retrieving HTTP responses from remote servers. Akka HTTP performs all the connection management. It is the most convenient way of using Akka HTTP's client-side functionality. Let's implement our examples with 3 levels of client-side API. We want to get our IP information using the Teles API. First, let's define our IP info class. It will be a case class that contains IP, country, and time zone. The response will be a JSON object, so we need a format, which will convert JSON objects to our class. So, let's define our JSON protocol object that will extend default JSON protocol from spray.json package. This object will contain an implicit format for our class. This format means we are able to read, write it to from JSON. Now, let's play with the connection level. Akka HTTP is implemented on top of Akka Streams. So, let's think about request and response like a stream. HTTP will provide us with a flow that will consume HTTP requests and provide HTTP responses, all using the same connection. This has the potential of being faster than reconnecting each time you want to send a request to a service. So, we need to define a source of requests and a sink for the responses. First, let's define a connection flow such that its input will be HTTP request, its output will be HTTP response, and its materialized value will be outgoing connection type, which represents a prospective outgoing HTTP connection. We will use the outgoing connection method to create our flow. Then, let's define our stream. We will use the single function from the source object that takes a URI to define our source. Next, let's connect it with our connection flow and run it with sync. That is a feature of HTTP response. Let's map on it and print our response. If the status of response is OK, let's unmarshal the response entity and convert it to our IP info class, and then let's print it. If the status of the response is otherwise, we will convert the response to string and print it. Let's run. Great! Here is the information of my IP. Now, let's play with the host level. In this level, we will let Akka HTTP manage our connection pool for a specific endpoint. So, as the first step, we will create a pool of connection. We will use the cached host connection pool function that will return our flow, which is also called a pool client flow. This flow consumes tuples of type HTTP request, T, and produces tuples of type try, HTTP response, T. The API includes an object of type T with the request and the response. Think about this object as an identifier to identify this response for this request, because our pool will have more than one connection and generates responses in an order that doesn't directly match the consumed requests. So, on our example, we'll just use an integer value. Now let's create our stream. We will use a single function from the source object again, but this time we'll take a tuple of HTTP request instance, and our identifier, let's say, will be 4. Then let's connect our source to pool client flow and run it with sync. And here is the handling of the response. Let's run the test. Great! Now, let's move to the request level, which is a very common way to use client-side API. It's very simple. We will use a single request function from the HTTP class that takes the HTTP request instance. Here, we now have the same code for handling a response. This API is the simplest, yet most limiting of APIs. I'd recommend starting out with this API in your applications, and if you see the need to move to another API for performance reasons, you know how to use the other APIs already. Let's run. Excellent! We can now successfully work with client-side APIs. See you in the next video, where we will work with server-side API.